This topic is converting from a radical to a rational exponent and back. Here are just some of the properties of a radical. This piece is called the radical sign. This piece is called the radicand. And this piece is called the index. So here are a couple exponent rules when you're going from an exponential to a radical. The first rule is a to the 1 power. Notice where the base goes. It goes underneath the radical. Then the 1 is the power, and the n is the index. So here's an example. We have 3 raised to the 1/2 power, and we want to rewrite it as a radical. So we say, there's our radical sign. The 3 is going to go underneath. The power is going to go underneath. And then the denominator is going to go out in front. So how we say that is the square root of 3. Now when you have a square root, you can just leave it like that. You don't need to have the index of 2. Here's the second rule. We have a to the mn. You can write it 2 ways. When you have this exponential, this is my radicand. But notice the difference of where we put our m. Our numerator can either go out in front or underneath. And then our denominator is our index. So here's an example. We have a radical sign. Our base is 5. So how we say this is 5 to the 2/3. Here is our base. And then our 2 can go underneath. And then our index is 3. So we say the cubed root of 5 squared. I'm just going to simplify that. 5 squared is the same thing as 5 times 5, which is 25. And then we have the index still as 3. Here are some more examples of converting from a radical to now an exponential. So what we have is the square root of 6, and we want to convert it to an exponential. So my base is 6. My power is 1. And my index, since the square root, we don't necessarily put the 2 there, but I'm going to put it there for now. So that's going to go underneath. So we say it's 6 to the 1/2 power. Here's a second example. Our base is 3xy, and our power is 5. So that's going to go as my numerator in my fraction. And then again, my index is not there, so that's say it's a square root. So that's going to go underneath. So we say 3x, and we have to put a parentheses like we did with this radicand. So it's 3xy all raised to the 5/2 power. Here is a radical of the 9th root of x to the 3rd. So our base is x, our power is 3, and our index is 9, so that's going to go underneath. Well, we can simplify that fraction, 3/9, as 1/3. So we say x to the 1/3 power. This example, the base is negative 12, and we're raising it to the power of 3, And then our index is 4, so it's 3/4. Here are some problems where now we give you an exponential, we want you to convert it to a radical. So in this case, the base is 32, so that's going to go underneath. The power is 1, and then the index is 5. So we say the 5th root of 32. And then we see if we can simplify that. We can simplify the 5th root of 32 as 2 times 2 times 2 times 2 times 2, or 2 to the 5th. And then we have the 5th root out in front. Remember that if you have a power and an index equaling each other, everything cancels out, you're left with just the base of 2. Here's an example B where we have x raised to the negative 4/3. Well, we can rewrite this as a positive power. So it'd be 1 over x to the positive 4/3. And now let's take care of that denominator as a radical. So it's 1 over x, 4th power, index is 3. This can reduce down to x cubed and x. Well, I can take out this piece as an x, and then I'm left with a cube root of x, and then a 1 over the top. Now we have a 2 base of y, power of 3, 4th root, and then z, power of 1, 4th root. And what you can do is you can combine these two radicals into one radical. So it'd be 2 y cubed, z to the 1, and then 4th root. This last example has a negative power again, like the example above. So we say 1 over negative 32, and now we raise it to the positive 4/5 power. And now we can rewrite that denominator as negative 32, 4th root, and I'm just going to put a 5 out here.